Hello again and welcome back to Advent Code 2025 in MIPS assembly for the PlayStation 2. We're up to day number 9 and I will be upfront, I did not correctly completely finish day number 9 in assembly for the PlayStation 2. And that is because it got very difficult. It was quite tough. So first let's have a look at what our problem is today. Okay, this is called movie theater. It's another grid problem, and not as fun a grid problem as the previous one. We have all of these coordinates. We're given a list of coordinates, which sort of, if you map them out, show up in a grid, right? And we want to try and make a rectangle, as large a rectangle as possible, using any 2 points as the corners in our rectangle. Right, so you can make a rectangle between these 2 points here. It would just be a very thin one, or you can make one like this. No, it's kind of a large one. And that's fine. Part 1, you just find the biggest rectangle you can make. That's not a problem. That's not a problem. Part 2 is the problem. It turns out that these coordinates you have is a path, and anything that maps out, well, it's a path that maps out a shape, and the only valid rectangles are within the shape, not out, and don't go outside the shape at all. So this limits where you can make valid rectangles, as we can see on this one here. Right, you can make straight lines here as well, very thin ones. You make a fairly large one here. Right. So this is the big problem, and it gets even bigger because of this thing right here. Every input, I believe, has something like this, and it might not be obvious what this is, so I'll draw it out. I will draw it out for you, so you can see what it is. So let me bring in another window here. Okay, so here is our window here. So the shape is roughly oval. So let me get an oval shape here. Let's make this a little bit so it's not so wide. Should be visible. Right, the shape is roughly oval, like this. And somewhere in the, I think it's, okay, so it decides to change shape. If you did, fine. There's like a very thin bar that goes through like this. Right? So, in part 1, your biggest rectangle is going to be something like here. Right? Your biggest rectangle is going to be something like this. But in part 2, this would be illegal because of this bar that's going through the center, which has squares that are not part of the shape in it. And so your largest shape is going to end up down here somewhere, like either down here or up here. So that's the issue. Determining when you go out of the bounds of this shape is the problem, and it's the problem that I did not entirely solve. But let's see how badly this went, shall we? So we've got our solution thing here, right? I've got a point list, I've got ASCII num, I've got my input, I'm ingesting things, again we've got commas, right? And new line characters. We're either, if it's a comma, we've got the first number, if it's a new line, we've got the second number. Right, we convert the numbers into binary. So So go through that loop, ingesting all those numbers, convert num here, right? If it's 0, then we go to the next one. Like it could be an empty line. Convert it. We put it into the point list here. Yada yada yada. We're going on like x point, y point, depending on the value S1 that we came in with. Oh, sorry, S2. This value here. We're either doing the x point or the y point, right? So the x point goes at the 0, and the y point is offset by 4. So each entry in this this point list is 8 in length. We multiply it by 8 there. Yeah. Everything's fine. Yep. Okay, and the x point is the one that increments the length of the point list. So when we're finished, I take the very first point and I put it in the last point in the list. So I'm making this into just a complete shape, right? The end connects to the beginning. Just for whatever reasons. I think it makes it easier going through my list to make sure I get to the end of it correctly and that sort of stuff. Make all the things correct. So I've got next. Why does next take me there? Oh, was there space in there? Yeah. So we've got our big list of points, and we go to the silver solver. There's nothing else down here. Convert ASCII is still basically the same. That's fine. We go to the silver solver. I've got a couple of loops here, an outer loop and an inner loop, and so I'm just going through every point in the list, going trying every other point in the list. So you start you start at point 0, and you compare it with point 1, 2, 3, 4, 5, 6 until the last point, and then you start at point 1, and you can connect it to 2, 3, 4, 5, 6 on, right? So you're progressively getting slower, smaller comparisons. It's not a very fast way of doing it. It's a simple way of doing it. You just brute force it. Just everything. Just all the lists, all the calculations. And it just jumps to this calc area. And I've got a set less than here, right? So if it's less than S4, which is probably what, yeah, S4 is what comes out here. No, S3. So if S3 is less than S4, it'll come out as a 1, which will branch us to over here. So S3 comes out of calc area. S4 is probably holding my presently largest value, and if S3 is not less than S4, then we put it into we move S3 into S4 and we store that in silver res. So we're storing the largest, updating the largest value that we've found so far in silver res, and that's it. That's it for the solution. Apart from the calculating area, which I back up a lot of. I mean, it's longer than it seems to be. It looks like it needs to be, because it's got a lot of these backups here. So back up all these registers. I load out S1, S2, which I think are my X points. Right. S1, S2 are the two that I'm comparing. These are the x coordinates because it's the 0 offset, right? So I need to see if I need to swap these around. Because I want to subtract one from the other, I believe. Yeah, I want to subtract one from the other. So if I don't need to swap them around, then we jump to this no swap x. Otherwise, we load them differently. We load S1 with S6 and S2 from S5. And we do that subtraction there to get the difference. We add 1 to S4 because like even if you're doing the same point, the counts as a 1 width, right? So you actually you're counting widths from 1 instead of from 0. So yeah, or distances from 1 instead of 0 essentially. And so now we do the same thing for the y, right? And then we multiply those together. Multiply S1 by S4. So the difference in yeah. So basically, yeah, your height by your width of your rectangle. And that gives us our result in S3, and that's the area. Alright, so that's the silver part. Easy enough. So once that's done, we go into the gold part. So in the gold part was kind of the same. We've still got the same, I think basically the same loop going on here. So gold, silver, back a little bit here, loading the point list. Load is 5 there, we shift it left 2, we add there, so we've got our starting and our ending points for our loop. All the same sort of stuff up here as in the silver one. We're calculating the area. Then I load out the area that we have in the gold result, and if it's not larger, if the area that I've just calculated is not larger than the gold res, then we're going to skip on to the next one anyway, because there's no point even checking to see if it's a valid rectangle if it's not going to be a larger area than the largest valid area we've found so far. Right. So if that is the case, then we go into exclude points. We're going to jump to exclude points, and if that, as you see the comment here, if this returns 1, it's not valid, and then would branch to the next iteration of the loop anyway. But if it is valid, then we end up storing this result from here, from this calc area, into gold res. Right. So that loop there is not too interesting, not too amazing, but now we get into trying to determine whether these points are or this rectangle is valid. So we go into this exclude points here, back up all these registers, something about making rectangle points here. So I'm checking about these whether I'm swapping X and Y locations. Swapping around the X and Y's, right? So I've got T1 is the X, the T1 is the smaller X, and T2 is the bigger X, T3 is the smaller Y, T4 is the larger Y, right? And we go through this point list again, and I've got this exclude points sort of loop thing here. These are candidates, so I load out, I'm loading out all the other x and y coordinates from all the points in the list, and I've got a bunch of checks here, right? So if t1, which is the smaller of the x, is less than s2, then that will be a 1, right? And that will be a 1, and we won't branch. If t2, this one here, is greater than or equal to s2, then we'll branch. It'll be a 1, and it'll be a 1 and we won't branch. No, wait. Now, if it's greater than or equal to, then it'll be a 0 and we won't branch. Such a pain. So this gets set to a 1 if s2 is less than t2, or it'll be a 0 if t2 is greater than or equal to s1. Oh no, sorry. If s2 is greater than or equal to t2, right? Or essentially, if s2 is less than t2, then it'll be a 0 and would branch. So, and then we've got another check here. These are for the y ones, t3 and t4, right? So, if we go through all of these checks, if any point is inside, we return a 1 here. So I think I'm essentially checking. What am I essentially checking here? It's kind of hard to tell, because that there is the x and y of S6. Jump to exclude points end, that's a 1. I think it really is kind of hard for me to tell what I'm actually checking here at this point. Right, because I'm going through this loop and writing out all the different candidates, right, that are in the list, and if it's less than, so the x is less than, but that doesn't seem like it would be a valid sort of thing. I think I know. I get what I'm doing here. Right. Okay. Right. I get it. I think I get it now. Because what I'm doing here, okay. Let's bring this back for a second. Right. So, oops. I didn't mean to do that one. Let's bring that back a second. And let's get rid of these. So let's say I've got I've got 2 x coordinates, something fairly large. I've got these 2 sort of x coordinates points here and over here. And let's say I'm comparing it to a coordinate that's like, well, essentially, like I've got those 2 coordinates there, I'm comparing it to a coordinate thing sort of here, right? And if I end up with one that's on one side of this point and one that's on the other side of this point, then I'm probably outside. Like one of these is probably outside of the rectangle, outside of the shape, right? Because all of these these points, well, the shape it tends to be like where are we? You know, there's 1 point there, then there's 1 point up here, and then there's 1 point over here, and then there's 1 point up here. It's sort of doggling a shape out like this. Is what it's like. So I think that's essentially what I'm doing here. So I'm checking if that at least sort of one of them's inside. I'm checking that at least seems like at least one of these points is inside, or something like that. Anyway, I think that's right. So, yeah. So if I get through there, there's like none of these points are inside at all. Then I just exit out with a 1. Otherwise, I go into these checking for an intersect to see if I'm crossing a line. So, if I'm just looking at the same point, there's no reason to check if there's an intersect. I think that's right. Yep. So we skip it if we are just at the same point, we're looking at the same point. Otherwise go into here. If this returns a 1, there's an intersect, so it's invalid. If it's not equal to 0, we go to exclude points end. Right, and seeing it returns a 1, we can just go straight with that and we get back out. Otherwise, we go over here and we go and check the next points. Something like that. But then it seems a little bit weird if we're going checking for the next loop. I think. Wait, what is it? No, I think am I? Is it? Well, the thing is, right? Each point on this. See, you got a grid sort of like this, right? Let me bring this back again. Seeing the points are laid out like these red ones here, right? Actually, this probably doesn't work unless there's another one over here, and that there is also a red one, right? One of these points in all these tests is definitely on this grid, and another one is made by, like say you're doing this one here, and it makes this rectangle. Right, so this is a phantom sort of point out here. So, what I'm doing is like checking these ones here in between it, I think, and then see if we go outside, or if we end up crossing a line or something. Anyway, you see, even looking back at this, I'm getting confused, and I definitely got confused back then as well. So anyway, we're going to now test if there are intersects, right? Because if we end up crossing through a line, right? Again, if I bring this thing back here a second, like say you've got this in here. If our points are on either side of this, and it crosses through, then it's definitely going to be outside, right? You can't, if we can't cross a line, we have to be on it at best, right? We can't cross it. So, we're going looking for intersects. And go in here, go and back up all these things again, right? As got some comments here. Oh, sorry, get rid of this. So we're in our test intersects, right? Back up all these registers, of course. We've got some comments here. T1, T2 hold our X values, T3, T4 hold our Y values, S2, S4 hold our the previous points, X and Y, and these are the second points, X and Y. So we load out the second points, X and Y. And then we go run intersects, jump through run intersects, and now you can see everything's getting worse. All these comments of what things actually are. So we're going to run intersects. If S2 is equal to S3, then we go for a vertical intersect. If T3 is equal to T4, we branch to no intersect. We set S1. So if S4 is less than S5, it'll make it a 1. So we take this branch and go to in skip swap Y. Right. Otherwise, we're going to be swapping around these Y positions. And then we do this these checks here. And the no intersect. If those are less than, doing things there. And then we've got these more checks for if things are less than or greater than whatever. Branch to these second X, and if they aren't, then we end up going to this jump to intersect. There's other jump to intersect down here. Let's swap those around. So these are the horizontal intersects. Now, if I actually get rid of this again, let's clear this all off. If I can. So if I know what I'm doing here, essentially, I've got a couple of points, and I want to see if they intersect, intersect between a couple of other points that I've come in here, right? So if these points, thing points are between these 2 points, these red points, I need to test if there's an intersect. Right. If the blue points are like down here somewhere, I don't have to bother checking for an intersect. So that's what I'm doing there. And the same thing for the vertical intersect one. You just swap it around. Right. If I've got these 2 points over here, and I've got a couple of points over here, I need to test if there's an intersect between them. If they're over here, they're outside of it, then we don't have to bother. Right. So that's what I'm doing. Checking to see if I need to do intersects or not. So I've already checked the points inside the rectangle, so if we made it here, it will intersect. I don't know if that's actually true, because I've already got some jumps to no intersect. So that comment might be dated. If T1 is equal to T2, it's a no intersect. So these are on each other. They're not going to intersect with anything. Then we see if we swap around these T2, S2 and S3. And now we're checking if those, then it's not an intersect. Otherwise we branch to these second vertical one. We've got some branch here for no intersects, and if we make it down here, it is an intersect, and so we return a 1 in S1. Otherwise, if we make it to our no intersects here, it's a 0. And I've got a jump here to the end, and I shouldn't. I should just have a JRRA, and just jumping for no reason, whatever. In fact, I could have put it just above here. JRRA. Could have just done like this. And it would have been slightly faster. In fact, I could have even, so long as there's no other references to it, I could have even put the JRA over here and just got rid of that there completely. Anyway, and so that's all my checks for intersects there. Now, you can say that's all the code there. So why isn't that I've like not completed this completely? You might wonder. Well, if I can find it, my gold solver here. Yes. There is a little bit of a trick here. I think it's this one here. So that I only go through about half of the gold loop. Let's see if I look at the silver solver. Is that by 3? Add that to S5 to make it a 7. S7 is the end of it. Here, I think. Yeah. See, I do a multiply by, what is it? 2. So I multiply it by 4. I multiply it by like 4 instead of by 8, and then add it onto there. And so that essentially makes it, I only do half of the shape. And if we go like, because if we go back to the shape here, right? Again, I need to go back to clean up my shape. Through, I don't know, luck or whatever, my starting point, I found out that you know, I've got not that shape. Get this thing here. Right, the shape here, I don't know exactly where my starting point was. And remember, our shape had this bar that goes through out like this. I'm not exactly sure where my starting point was, but it must have been somewhere. Where would we say? It was somewhere near that. No way, it wasn't somewhere near the bar, was it? Except I was like halfway through it. It was somewhere about. Where's a different color? There's a different color. The starting point was somewhere like around here, or something, right? So if it was going around this way, or even going around this way, right? So long as we're doing about half of this loop, there's a good chance that we're going to get the largest shape we can, because the largest shape is going to be within either this side or the other side up here. Now, if I was smart, what I would have done is essentially cut this in half and then done the two sides separately and looked for the largest shape, right? Instead of like putting them together, I would have done half of it, and then I would have made another starting point when I got to that other side, and essentially started again from over here, going that way, whichever way going the same direction that it was beforehand, and checking the other side to see if there's a 1. And so I probably could have, if I were to add that in to my solution now, that'd probably be a general solution that would work. Essentially, do half and then sort of reset, and then start from here, going back here, do another half, or do the final half, right? If I did that, it would probably be a general solution that would work. So I basically do have the solution. I just have to add in one reset over here to make this the starting point over this side, and then go around and do half of it again, and that would probably be a general solution. But as it is slightly a not solution right now. Well, that's alright. So, does it run? Well, you should know that it runs, because I wouldn't be making the video if it didn't run. And we can see that the final result down here is the target, right? Because I've noticed that if I ran halfway, it spat out the correct result, which is how we end up in this mess. And you can see the top part is correct there as well. So, all in all, the solution isn't that long, and kind of isn't even that long to explain compared with the day 8, but it's sort of a pain in the ass and harder to understand, harder to wrap your mind around what's going on. And probably the biggest problem out of everything is the fact that you need knowledge of the shape in order to write this solution, right? You can't just go, well, I don't know what the shape is, I'll just write a general solution that will work for anything. If the shape wasn't an oval like this with that bar sticking through it, then this solution wouldn't work. And even writing it so that it would check both sides of the oval separately for the largest rectangle wouldn't work unless all of the shapes were oval, varying degrees of just oval, right? If it was completely different kind of shape, doing it like that wouldn't work. So, kind of annoyingly, it requires, this solution is kind of specific to the shape type, and just being a matching sort of problem, really. And so that is kind of annoying. But anyway, enough of that doom and gloom. The final announcement of redoing the day 2 solution, I will be doing that as a live stream on this coming Friday, Japan time, March 20th. I will schedule the stream in the coming day or two, so if you see that coming up, please look out for it, and I hope to see you there. I hope to see you next year, where I will do something else fun, hopefully. Until then.